So here, why it is why it is echoing. Here though, now it is okay. Can you listen? Yes. So molarity. Okay. Now molarity is, if we see the definition, okay, that is your number of moles in 1 liter. Okay, number of moles in 1 liter, and 1 liter can be solution, it can be gas also. Okay, so if we talk about liquid, so it is your number of moles in 1 liter of solution. Okay, mostly solution we make. In gas also same thing, number of moles, okay, in 1 liter gas, whatever gas is there. So 1 liter of gas. Okay, so this is basically, this is the this one definition. Now you see, suppose somebody asked me that, let's take some simple example first. Okay, in pure water, okay, we are taking just pure water, liquid only, pure liquid. In pure water, how many moles are there in 1 liter? Okay, how many moles are there in 1 liter in pure water? So whatever is the number of moles in 1 liter, that will be the molarity of water. Okay, so if we find moles in 1 liter, or somebody says find the molarity of water, okay, or you have to find the molarity of water, that is same thing. Okay, same thing. Now what it says, that what is the definition, that in 1 liter you have to find the number of moles. Okay, so in 1 liter, now how to proceed? Suppose you have to take 1 liter water. So 1 liter water, what is the weight of water? 1 liter water, you can say 1000 ml. Okay, 1 liter water is also 1000 ml. Okay, now 1000 ml means 1000 gram, because the density of water is 1000, oh sorry, 1 gram per ml. Okay, so that is the density. Now in 1000 gram, how many moles are there? In 1000 gram, how many moles? X moles. In 18 grams, how many moles? 1 mole, because that is a molecular weight of water. 1000 gram, X moles. This is, so X will be 55.5 moles. Okay, so when we have 55.5 moles, that is in how many liter? In 1 liter. So I can write like this: in 1 liter water, 1 liter H2O, 55.5 moles are there. So molarity of water is 55.5 molar. Okay, It is written as molar. Okay, whatever is the molarity, we just write molar, or we write capital M. Okay, instead of molar, if you don't want, just write capital M. So that is also the molarity. Okay, have you understood? Molarity of water is 55.5. That is for the pure water. Okay, that is for the pure water. Now suppose another thing I want to take is about the solutions, molarity of the solutions. Okay, molarity of solutions. Now in molarity of solution, what is there? Solution is made up of solute and solute and solvent. Okay, so during this means if you got this solution, so you have to find number of moles of solute in 1 liter of solvent. Solute I am considering is as it is as a solid one. For example, you can take NaCl, glucose, okay, sugar. So these are solid solute. So when we dissolve them, okay, in a solvent, you can take water. Normally we take water, but okay, this can be any solvent, alcohol or kerosene, petrol, whatever is there. So solution is what? Solute and solvent. So here, if they ask about the solution, molarity of solution, so it means that number of moles of solute in 1 liter of solvent, that has to be there. Now suppose let's take the example. Okay, let's take the example. Okay, let's take suppose 18 gram. Okay, 18 gram glucose is dissolved in 500 ml water. Okay, so glucose is solid, everybody knows that, solid powdered form. Okay, this is the, now this is the solute, this one is solute and this is the solvent, so this is a solution. Okay, and we have to find the molarity of the same. Find molarity of solution. So first you have to see, okay, number of moles you have to find. Number of moles of what? Number of moles of solute you have to find. Okay, you don't have to find the number of moles of solvent, no, it is not required. Just find out the number of moles of solute. Okay, so moles of glucose, moles of glucose is 18 by 180. 18 is the given weight, 180 gram is the molecular weight of glucose. Okay, we calculated it in the previous classes. So 180 gram is the molecular weight, 18 gram is the given weight, so that is your 0.1 mole of glucose. Okay, understood this one? 0.1 moles. Okay. Now 0.1 mole glucose is in 500 ml water, is in 500 ml water. But how much water do we need? 1 liter, 1 liter of solvent. So 1 liter means 1000 ml. Okay, 1000 ml water. So how many? It is double, so it will be 0.2 moles of glucose. I think you understood this one. So 0.2 moles glucose is in 1000 ml water. So what is the molarity? Molarity of solution is 0.2 molar or 0.2. Okay, understood this? So just I am repeating this one. 18 gram of glucose is dissolved in 500 ml of water. Okay, we have to find the molarity of solution. So first find out the moles of the solute, then you have to see how much ml is there for the solvent, and respectively you have to calculate for the 1000 ml. Okay, this one. So that is all. Any confusion you can ask anybody. That we did, yes, here only. Point 1 is in 500, so point 2 is in 1000. 1000 is important, means whatever is there, whatever moles are there in the 1000, that will be the molarity. Any other doubt? Okay. Now there is also a formula for the molarity. This formula is just the same thing. So molarity is the weight divided by molecular weight. Okay, for solute in 2000 upon volume in ml. So that is the formula. Okay. So this is basically the formula. Okay, this is basically the formula. So we can solve this question by putting it in the formula. So molarity is equal to 18 by 180. 18 is the given weight, molecular weight is this, in 2000 divided by 500, so that will come as 0. Okay, so that is the case here. I told you by this and by this, so that you can understand each and every point. Have you understood this one? It is the given weight. This weight is given in the question, this 18 gram. This is the given, this is given weight in the question. Okay, I should write given weight. Given. So that is your given weight in the question, and it's for the solute only. Solid solute should be there. Okay, liquid solute. If it is liquid solute, then the whole scenario will change. Okay, so use it for only solid solute, just like NaCl or something like that. Okay, now let's take another question. If 0.9 moles of glucose dissolved in 100 ml water, what is the molarity? If 0.9 moles of glucose dissolved in 100 ml of water, what is the molarity? So what is the molarity? 9. Yes, correct. Okay, so how that is very easy. 0.9 is dissolved in 100 ml. So we want in 1000 ml. In 1000 ml it will be 10 times, because 100 and 1000 are 10 times, so it will be 10 times, so 9. So molarity is equal to 9 molar. That's simple. Everybody getting it? Okay. Okay. So let's take another question. If, okay, solve it fast. Molecular weight of NaCl is 58.5 grams. Okay. How many grams of NaCl, okay, should be dissolved in 250 ml water to give 0.01 molar solution? Okay, so this is the molecular weight. How many grams of NaCl should be dissolved in 250 ml water? Okay, so that we get a 0.01 molar solution. Okay, to solve it, 2 gram. Any other answer? Okay, let's solve it. So you see, that is your 250 ml, okay, water, and 58.5 gram. Okay, understood that. So molarity is what we did in the formula. So weight given, you have to find out what should be the weight dissolved. Molecular weight is given to you, molarity is given to you, volume is given to you. Okay, so try to solve it. So molarity is, okay, that is your molarity is your 0.01. Weight you have to find, which is not given. Molecular weight is 58.5 into 1000 upon volume is 250. Okay, so let's check it. So 250, so that is 4. Okay, and then it is your 0.01 and 58.5, so that will be, so weight will be, okay, 58.5 10 to the power minus 2, I can write like this, divided by 4. Okay, so that is your 4 ones are 4, 4 4 is 16. Okay, then that will be 16, 25, 4 6 are 24, so 10 to the power minus 2. Okay, so that is the answer. So this is the answer. Okay, see, first you have to see, please note down this formula. Molarity is your weight given. Weight given is what is given in the question. In question, we there is no weight given. Instead, they are asking to find out the weight. Molecular weight is 58.5. 1000 is 1000. Now you don't have to do anything. Volume in ml is 250 ml. Molarity is how much? 0.01 molar. That is the molarity. Okay. So just put this molarity. Weight you have to find. This weight you have to find. Okay. What should be dissolved? 58.5 gram is the molecular weight. 1250 ml. If you have still any doubt, you can ask. Any doubt? Please ask. Okay. Now let's take another question. Okay. If 10 grams of glucose is dissolved in X ml water, okay, to give molarity of 0.5 molar, okay, you have to find X. Okay, 111.1. So let's solve it. Okay, so just you have to write the values in the formula. Okay, this is, so you can solve it for X. Okay, just solve it for X and that will be O. Okay, so 18 fives are 90 basically, so 9 will come here and then you can divide this. Okay, yes. Okay, so this is one aspect of molarity, easy, okay, based on the formula you can do that. Now next concept in the molarity is your dilution and concentration. So here dilution and concentration of solution. Okay. Dilution means less number of solute per liter. Concentration means more number of solute. Okay, that, but you have to compare with something. Okay. Now suppose I have, let's take example for this. Example for dilution. Okay. I have 1000 ml 0.1 molar NaCl solution. Okay, suppose this is the solution. Okay, this is a solution. 1000 ml 0.1 molar NaCl solution. Yes. Okay, so let's take it 100 only. 1000 will be a larger quantity. Let's take 100. 100 ml 0.1 molar NaCl solution. Okay, this one. Now If the let's add some water to it. Okay, let's add 50 ml water to it. Okay, after addition to 50 ml water, okay, solution will become dilute, so that there will be a diluted solution that we will have. Okay, so we will have a dilute solution. So diluted solution is the result. Now, how much is the molarity of the diluted solution? What is the molarity? What is molarity of diluted solution? Now, how to find this? Okay, now suppose first you have to understand this 100 ml 0.1 molar. Okay, understand this one. 100 ml 0.1 molar. So 100 ml 0.1 molar means, it means what? Okay, so first understand 0.1 molar. So 0.1 molar solution, if we 0.1 molar solution means what? It means that 0.1 mole is in 1000 ml. So that is the because that is the definition of molarity. Molarity. So for the molarity, the volume of the solution should be 1000 ml. Volume of the solution should be 1000 ml. So when we ask anything about 0.1 molar, first thing that will come in your mind is the 0.1 mole is in 1000 ml. Now how much is in 100 ml? Okay, so how much is in 100 ml? 0.01 mole. Okay, 0.01 mole is in 100 ml, and that this is also a 0.1 molar solution. Okay, molarity do not change. If you, okay, suppose this is a 1000 ml of solution. Okay, sorry, this is a 1000 ml solution. Okay, its molarity is 0.1 molar. Okay, you take out 100 ml out of it, so its molarity will also be 0.1 molar only, because 0.01 moles are in 100 ml. Okay, so from here to here, if we go 1000 ml of 0.1 moles. Okay, so that is your molarity. See, okay, let's understand this way. So molarity, what is the formula we took? Molarity is your molecular weight into 1000 upon volume in ml. Okay, now this one is what? Weight upon molecular weight is your moles. Okay, this moles, so I can write this again. I can write this as number of moles n into 1000 upon volume in ml. Okay, that you know already. This is the number of moles. Now understand this. If we take this 100 ml of, okay, 100 ml of this volume. So volume is your 100 ml. Number of moles are 0.01. So molarity is your 0.1, isn't it? If you take, yes, yes, ask. Okay, if I take 0.1 moles into 1000 upon 1000, so again the molarity is 0.1. This I am talking about. Okay, now in the practical view, okay, suppose this is your 1000 ml bucket. Okay, this is a 1000 ml bucket, and there are so many moles of NaCl which are there. Okay, this is suppose NaCl or something something. Let's take NaCl. Okay, and somebody take out. Okay, somebody take out some volume of this. Okay, somebody take out some volume of this. So this will contain some moles of glucose and some water. Okay, so in that 100 ml of this 100 ml, suppose you are taking, so there obviously 0.01 moles of NaCl will come. So this solution will also have molarity of 0.1. Volume decrease, okay, in the same respect, number of moles decreased. All of you are getting this. Okay, so that is why molarity doesn't, if you take some amount of water from this larger solution, molarity will not change. Okay, so let's go back to our question. 100 ml 0.1 molar solution. So in that 100 ml we have 0.01 moles. 100 ml has, why? Huh. What molarity? Why should it change? Yeah? Molarity is what? Number of moles per liter. Okay. So from this perspective, 100 ml. This perspective, you have to see how much is in the 1000 ml. Okay. Suppose initially you make a solution. Okay. Suppose you take 50 ml of water. Okay. 50 ml of water, and you dissolve 0.5 moles glucose to it. So what is the molarity? What is the molarity? Okay, 0.5 moles into 1000 upon 50. Okay, so molarity will be 2. Okay, this one. Now again, if I dissolve 1 moles, okay, 1 mole in say 100 ml, okay, sorry, in 500 ml, 1 mole in 500 ml. So again the molarity will be 2. Molarity will be 2. Okay, this is a different solution, this is a different solution. But okay, from this perspective, if you see, 50 ml has zero point 0.5 moles, 50 ml has zero point 0.5 moles. Okay, so 500 will have, okay, sorry, should write like this. 500 will have, okay, sorry, how much I took? 50 ml of water, 0.5 moles of glucose. Okay, so that no, that will not work here. Just that will not make any sense. Okay, understand in this way. How to make you understand? Okay, so this is your, let's uh, okay, there is a wall, okay, between this is a 25 ml solution, this is a 25 ml solution, there is a wall. Okay, this contain 0.25 moles. Okay, this also contain 0.25 moles, sorry, ml I wrote. Okay, moles. Okay, now this 25 ml 0.25 moles. So what is the molarity of this compartment? 0.25 into 1000 upon 25. Okay, this one, this cancels out, and this. Okay, so that molarity will be 10. Okay, same here, the molarity will be 10. These are the two different compartments. Okay, are you listening? So these are the two different compartments. Everything is same in these two compartments. So every compartment, these two compartment has 10 molar, this molarity. Now we remove this wall. Okay, suppose I remove this wall. So what will happen after removal? After removal, what is the volume? What is the volume? 50 ml, because now they will mix. So that is 50 ml volume. How many moles are there? 0.5, 0.5. Okay, so what is the molarity? What is the molarity? 0.5 into upon 50. Okay, so take 10 here, so cancels out here. Again, we will get 10. Are you getting? Okay, now reverse this situation. 50 ml is the total volume, and you take out the 25 ml volume out of that. Okay, you have to reverse that situation. I am just saying, I am not giving a question, and I am saying that this is your 50 ml this solution. Okay, now you take out 25 ml of this, suppose this one. So what is the molarity? Not getting. You remove the 25 ml, just remove the 25 ml. Okay, so yeah, obviously, but that is a easy question. I'm just making you understand. If you remove 25 ml, some of the moles will also come out. It is not just that only water will come out, NaCl moles will also come out, and that 0.25 will come out, because that they are evenly dissolved. It is not like this, these moles are sticking in the bottom, they are lying in the bottom, you will take out only water. No, it's not like that. They are evenly distributed. Okay, so that's why. So we were on the question. Okay, so this was the question. So 0.01 moles are in 100 ml. With respect to the 1000 ml will contain 0.1 mole. Okay, that's why I told you this is the important concept. What is meant by 0.1 molar and what is meant by 100 ml of its solution. I think everybody is getting. Okay, if you are not getting, please ask me. Again, I will repeat. Everybody getting it? Okay. So one thing you have to understand, even if I take 100 ml out of this 1000 ml, molarity will not change. Now let's go towards the question. Okay. So 100 ml contains 0.01 moles, and to this 100 ml we have added 50 ml. So total volume will become 100 plus 50, that is your 150 ml. We have not added anything to these moles. We have not added NaCl. We just added water. So moles will be same, 0.1 mole. 0.1 mole is there in 150 ml. Now you have to find the molarity of this solution. 150 ml, 0.1. So molarity is your 0.01 into 1000 upon 150. Okay, let's take out the 0, 100. Okay, this one. So that will be 1 by 15. Okay, 15 6 are 90 point. So it will be 0.0 approximately. Okay, so now what was the earlier molarity? That is your 0.1. Okay, earlier molarity is your where was it? Yeah, this molarity is 0.1, 0.1, 0.1 molar. Okay, from 0.1 molar, molarity has decreased to 0.06. Okay, so that is called as dilution. A decrease in molarity is dilution. Okay, have you understood this one? A decrease in molarity, that's my handwriting. Yeah, increase in concentration. Increases concentration. It is dilution. Okay. Then there is a formula for the same. We can also write the formula M1 V1 is equal to M2 V2. V2 is V1 plus X ml. Okay. Now if we solve through the formula, M1 is 0.1, V1 is 100, M2 we have to find out, that is your 0.06. Just we have to find out. V2 is your V1, that is your 100. Okay, 100 plus X that we have added, that is your 50 ml. X can be any ml. Okay, you don't know. So M2 will be 0.1 into 100 upon 1. Okay, so in that manner you can just calculate, so that will come as 1 by 50. Okay, so that is the formula. M1 V1 is equal to M2 V2. V2 is this, so 50 ml we have added. Okay, just to make it, so this is the formula based approach, and this is how you have to understand the root of this concept. Okay, but if you remember the formula, even then it's okay. So just remember this one: M1 V1 is equal to M2 V2. Okay, have you got it, everybody? Now let's go on to concentration. Concentration means increase in the molarity. Increase in molarity. Okay, there is an increase in molarity. So what is the increase in molarity means? Okay, increase in molarity means that the volume will decrease. Suppose, let's take an example for this. There is 500 ml water and the solution is 0.001 molar. So that is a solution. Okay, it can be of anything. Okay, this is a solution. Now suppose we heat it. So due to heat, evaporation will take place. Okay, so during evaporation only water will evaporate. Only water will evaporate. Okay, let's make a, it's a solution, NaCl solution. Let's take a NaCl solution. Only water will evaporate. That is the main crux of this. So only water will evaporate. NaCl will remain here in this container. Okay, so after evaporation, suppose the volume becomes, let's say, 450 ml. Okay, so what is the molarity? Suppose it is now X molar. Okay, so you have to find the X. Now how to find this? Same principle will be applied. Okay, you can use the formula or just you can just do all these things. So 500 ml 0.001 molar. Okay, so you have to find the number of moles. So how to find the number of moles, because that is your molarity of solution, it is not showing number of moles. So 0.001 moles are dissolved in 1000 ml. That is what, according to definition, 0.001 molar means 0.001 moles are dissolved in 1000 ml. So 500 ml means half of it. Okay, so that we can take 10 to the power minus 3 by 2. Okay, 0.001 I can write 10 to the power minus 3 by 2. Okay, or you can write 5 into 10 to the power minus 4 moles. Okay, in 500 ml. Okay, this is the first situation, means here 5 into 10 to the power minus 4 moles in 500 ml. Now when evaporation takes place, only water will evaporate. So these are the moles of NaCl, they will not evaporate. So moles will remain same here, 5 into 10 to the power minus 4 moles. They will remain same, it will not change. What will change is the volume, that is your 450 ml. So these are the moles which are present in 450 ml. Okay, so whatever moles are present in 1000 ml, that will be the molarity. So just I'm writing X. Okay, X. So whatever is present in 1000 ml will be the molarity. So X will be 5 into 10 to the power minus 4 into 10 to the power 3 divided by 450. Okay, so that will be your 5 nines are 45, 90, and that will be 10 to the power minus 1. So 1 by 900. Okay, okay, 1 by 900. So that will become 0. 1 by 9 is 0.11. So 0.011. So that will become 0.0111, like that. Okay, molar. So X will be this. So now there is an increase in the molarity. So have you understood this one? Water is evaporated. So this, first you have to find the number of moles. Okay, just find the number of moles. Then you can find how much water is evaporated. Then from that you can just find the molarity. Okay, this one. So this is one approach. Okay, this is one approach. Now another approach is your, this same formula you can use, m1 v1 is equal to m2 v2. So m1 is your 10 to the power minus 3. Okay, or you can write 0.001 into 500. M2 you have to find. V2 is how much? 450, because V2 is your V1 minus X. Okay, so I can write this for information, 500 minus 50. 50 is evaporated, but you have the total volume, so no need to do all this. So M2 you can just write 10 to the power minus 3 into 500 divided by 450. Sorry, okay, 450. So this is the another way of doing it by the formula. Okay, so there is a decrease in the volume here. In the concentration, volume is decreasing, and in the dilution, volume is increasing. Okay, so in the dilution, what happens? Volume increases. Okay, so from 50 100 ml to 150 ml. So there is an increase in the volume. Okay, where I did that. Okay, so in the dilution, there is an increase in the volume. Okay, you have to add something, whereas in concentration you have to subtract something. That is why the molarity will increase. Molarity is inverse to the volume. There is an inverse relationship. So molarity is inverse to the volume. So that is the inverse relationship. And that is why this will increase. So volume will decrease, molarity will increase. So that is the inverse relationship. Okay. So do all the question regarding molarity. Okay. So we will do more question regarding molarity tomorrow. Then it will be normality, mixing. Okay. So okay, mixing is important, but we can't do here. Okay. So let's close in here. So there are a lot of other concepts. Okay, so you can now you can leave now. Okay.